Hello everyone, ito na naman si JP ng Programmer's Code Posting at pag-uusapan natin ngayon is something na palagi sa aking tinatanong. Paano ba maging data engineer? So ano ba yung path, yung roadmap para maging data engineer? And sinasagot ko to palagi with the Data Stack TV na data engineering roadmap, which is a visual roadmap. Nasa GitHub siya, isang malaking image lang siya na pwede yung tingnan kung ano yung isang level ka na or isang part ka na ng journey mo to be data engineer. And yun nga, so pwede mong tingnan yung mga pwede mong aralin. Okay? So it's mostly tools there, not really concepts, but I think it's okay to begin with to be a data engineer. So ito yung learn this, and ito yung getting started point mo to be a data engineer. And so before we actually begin to look at it and discuss it, kung di pa kayo naka-like and subscribe to this channel to, please like and subscribe. And if may mga tanong kayo, just go to the comments and ask questions. So yun, let's get right into this. Dito tayo ngayon sa Modern Data Engineering Roadmap ni Data Stack TV. So tingnan natin yung laman nito. So ito yung main na ano talaga, yung main na image na titingnan natin ngayon. So data engineering, how to be a data engineer in 2021. So yung very first dito is, well, tingnan muna natin yung legend. So may personal recommendation siya, may general recommendation siya, and mga cloud-based. And magbibigay din ako ng ng mga recommendations ko on or mga personal preferences ko at the very least. So yun, so let's talk about yung CS fundamentals. Ito sa right side, how does the computer work, how does the internet work, so first two, obviously you don't need to like super go deep into it, just alam niyo lang paano siya nagwo-work to some extent, right? And then also get version control. So inisip niyo bakit kailangan mag-get kay kay data, that's kailangan niyo pa ring mag-get kay data, syempre kasi gumagawa ka ng scripts, ang code or whatnot, right? So syempre you need somewhere to put it. Tapos if you're working together with a team, so obviously kailangan nyo gumamit ng version control, some sort of version control, preferably Git. Okay. Ayun, so ito yung preference ko din. So you might be using something else, I don't care, but ayun. So on the left side, meron tayong basic terminal usage. This is obvious, kailangan nyo mag-work with the terminal. Hindi nyo maiiwasan to. Okay, kahit na gaano kayo ka-advanced may UI based na gagamitin kayo, which is the goal, pero para maging open to everyone, obviously hindi siya perfect. So kailangan nyo pa rin mag-terminal. Okay. So data structures algorithms, yes, of course, although a lot of these things is in the context of pag magpa-process na kayo ng data, or kung i-store nyo yung data in a particular form, right? So kailangan yung alam nyo yung tamang algorithm na gagamit or tamang structure to store your data in, or for particular processing, or for processing man siya or storage man siya or whatnot, right? It depends. Pero hindi kayo, honestly, as a data engineer, hindi naman kayo magmano-mano mag-write ng algorithms tala unless nasa machine learning end kayo. Pero kung sa purely like data processing end, usually hindi nyo kailangan magmano-mano mag-create ng structures algorithms to implement, right? As long as alam nyo paano siya gumagana and paano siya pagaganahin with a particular set of tools, depende sa gagamitin nyo, right? And there are good books on this naman. So for example, kay Spark, which is spoiler, pag-uusapan natin in a bit, may books naman on Spark algorithms, how to use those particular algorithms kay Spark. So may books naman on that. APIs, REST, obviously. Bakit? So this is why sinasabi ko sometimes na malaking advantage maging full stack web dev as data engineer. Kahit na a lot of people don't really approve of the full stack kasi hindi mo alam gamitin yung hindi ka maging magaling sa front end or sa back end, super kailangan mo siya sa data engineer. Why? Kasi number one, for knowing back end means you know how to query your APIs and REST, right? Or sometimes you have to create your own, right? It depends. Depends din sa usage mo, right? You sometimes have to. So for example, for me on a couple of occasions, I need to create my own API server, REST server, REST/GraphQL server para paggagamitan ko with in combination with my data workflows. for reasons, okay. Especially with regards to jobs na hindi kaya ma-handle ng platform. Kailangan kong gumawa ng separate server, okay. So, it depends. So, kailangan nyo marunong din kayo if it happens, right? So, especially if it's on the data end, baka hindi na mag-bother yung sa product teams nyo, for example, kasi related naman sa inyo talaga, and hindi nila job description yun. Anyway, IPS and REST, right? Dagdag pa dito yung GraphQL. You need to know GraphQL din kasi papadagdag yung mga tao na gumagamit ng GraphQL. But then, yung basics talaga is REST. And usually, if may GraphQL sila, usually may REST sila. Unless they started from the beginning na GraphQL talaga, then baka walang REST API. So, you need to know GraphQL din. So, structured and unstructured data. So, structured versus unstructured, we'll talk about that in later video, siguro super short video lang. Pero essentially, ito yung mga example sa structured data is yung mga relational data mo, yung mga nasa tables. Pag structured data, mostly yung mga mga blobs mo, yung mga files, right? So, we'll talk about that more in a separate video, maybe a short video lang. Mga Facebook Reels, charot. Right, ayun. So, serialization, essentially how you will convert your data into form that can be transferred. So, essentially, that's basically it. So, for example, may objects ka, how do you make it into a bit stream, for example, so you can transfer it somewhere, or I won't go deep into that, but yeah, baka madaanan natin some sort of similar things, right? Math and stats, obviously, kahit the basics lang, right? But if you're going more into like into the analytics area, naging analytics engineer ka, sometimes papagawin ka ng analytics mismo, so you need to know like at the very least ang basic math and stats, like basic stats, basic math. I don't need to go deep naman, for example, into like the derivatives, for example, unless you're working with with deep learning, really. Although you might want to check out like linear algebra to some extent, right? Depends pa rin. Yun, so CLI, Vim, shell scripting, cron jobs, obviously you need to know these then. CLI, you need to know like the basic feel of how to work with CLI tools, like para like, kasi like most of these naman follow some sort of like intuition, some sort of template na at the very least alam mo na yung command na yan, usually may dash help. So kung hindi mo alam gamitin yung CLI, mag-command ka din dash help, makikita mo yung laman ng paano gamitin. Kung properly made yung CLI, then you should be able to see something like that, right? Ayun. Vim, obviously you need Vim or something similar, right? That is already installed, for example, kasi if you have a server, it happens to me then sometimes na may server ako and then kailangan mag-SSH to a particular server, right? Kahit dun sa mga sa worker nodes, for example, it happens, and then you can't really install stuff there kasi kasi mawawala din siya, so next time mag-install ko ulit, doesn't make sense. So and you can't really open files there kasi it's pag mag-SSH ka, essentially like command line. So there's nothing, you can't really click it and it will open up as parang Word document or whatnot, right? That won't happen. So kailangan mo mag-open ng isang code editor, right? And that is usually something like Vim, right? And it depends kung saan ka naka-install, right? But usually the pretty common one is Vim, right? Depende sa Linux installation mo. Also, I forgot Linux. This is something that obviously you need to learn. Okay? Kasi like I've never seen I'm sure some people might disagree, but I've never seen a Windows na parang worker node. I've never seen anything like that before. I've seen like mga Windows na like lalagyan ng SQL Server, pero that's it. Pero as like worker node or driver, I don't think I've seen anything like that. But anyway, shell scripting, obviously kaya din marunong mag-terminal, maggamit ng CLI, kaya hindi kayo gumawa ng shell scripts. Okay? Ayun. Tapos cron jobs, at the very least, kahit na hindi kayo marunong mag-cron tab -a or whatever, at the very least alam nyo kung ano yung syntax, or at the least marunong kayong mag-google ng paano mag-build ng cron tab syntax, right? Okay, so at the very least, so cron, if it's something that you're not familiar with pa, is parang it's a software to run jobs at a particular time. So you can specify a one-time schedule, or pwede mong gawin na every 5 minutes, every hour, every day, or whatnot, or every year at this particular date, pag birthday mo or whatever, right? Something like that. So Usually sa Linux systems talaga to, pero may mga similar things obviously for data systems, no. A lot of data platforms use some sort of similar syntax, or exactly like cron syntax, or mga variations ng cron syntax, right, to schedule things, right. Ayun. So moving on, spent so much time there. Yung preferred niya dito is Python. We have the different languages then, Python. General recommendation is Java. It depends. Java's really not my thing. Pero a lot of, if nasa Hadoop space kayo, or nasa Apache space kayo, or whatever, right? So you probably need to know some level of Java. Kasi like if you need to dive into the source code talaga ng like what's screwing your application up, your data application up, then that's like a lot of the Hadoop ecosystem is written in Java, so there's no escape. So the closest thing that I use is Scala. So I love Scala, apart from the part that it is a JVM language. Kailangan ko mag-export ng jar para paganahin yung para gawing library yung ginagawa ko. So but anyway, thank God for notebooks, right? Nakapag-Scala ako dun without exporting to jars. Anyway, but yeah, general recommendation is Python, go for it, right? Go, pun intended. It depends, right? So, I've heard some people use Go, especially with machine learning projects, pero I've never really seen anyone use it in in big data processing. I've never seen really anyone do it. I don't particularly care as long as it compiles to something usable. Anyway, it depends then. It depends. Everything depends on something. And so testing, obviously you need some sort of this, right, to make sure that especially if you're dealing with data, right, when you're dealing with data, unit testing is really helpful. Why? Kasi usually when you're dealing with data, it's transformations, not mutable actions, right? So it's not mostly integration testing, it's mostly unit testing, right? When you're dealing with like data transformations, like it's easy to check like particular transformations of data using unit testing, so it's really helpful. Unless the code is so crap na hindi ka makapag-unit test, so you have to deal with integration testing. I'm not even sure what functional testing is here. Like, what is that supposed to mean? Is it an end-to-end test? Is it a UI test? I don't know. Depends. But you need to know some sort of testing thing, kasi you will have to write tests for your code. Right? Ayan. So and then finally we also have like database fundamentals like SQL normalization, the ACID transactions. So obviously you need to know SQL in data, right? That's the most ubiquitous language when you're working with data. So may normalization din tayo, obviously, for normalization and denormalization, like breaking stuff into multiple tables, right, and then putting them all back together. So normalization helps with with the redundancy of your data, para hindi ka pa ulit-ulit, just reference one bit of it, right, para hindi siya ulit-ulit, just reference it. ACID transactions helps with para if you have a couple of operations, pag masira ng isa, tapos pala sila, connected sila with each other, then hindi masisira yung setup mo. Pero that's just part of the ACID transactions. There's a lot of it in there. Like, so this, I don't completely remember ACID. Is it atomicity, consistency, isolation, and durability? I'm not sure about C. I'm sure about the same cap theorem though, which is the next thing we'll talk about. So we also have these things. Itong part na to kasi yung sa left side, SQL normalization, ACID transactions, is for like relational. Ito is more of sa big data space, right? So cap theorem is yung consistency, availability, and partition tolerance. So we won't talk about the entirety of that, pero basically itong tatlong to is trade-off. So you can only pick two sa cap. So either pick consistent and availability, walang partition tolerance, either availability lang and partition tolerance, walang consistency, and either consistency and partition tolerance is walang availability. Okay, so but this is also parang being slowly solved by a lot of newer databases out there, the NoSQL ones. So for example, Azure Cosmos DB has good availability and partition tolerance, pero like you can you can select your consistency. By default, meron siyang like eventual consistency. But if you want like strong consistency, you have to you have to have may drawbacks yan. For example, pag strong consistency, babagal siya konti, pero you make sure that once it's written, everybody sees the correct data. Right? Anyway, this is a discussion for another time. We can't really dive into everything here. It's overview lang to this. There's also a lot that we have to talk about. So, OLTP versus OLAP, this is essentially like your transaction optimized databases versus your analytics optimized databases. Essentially yung mga ano mo, like relational databases versus data warehouses. Okay, so pero you can go deeper on this on why that is. So I think we've talked about this a little bit then. I also have a video soon about like what data warehouses are, data lakes, and data lake houses. Ayun. I also have horizontal versus vertical scaling. Essentially, like, do you add more resources, more machines, or do you add more resources to one machine? So that's basically horizontal versus vertical scaling. And if you're dealing with some sort of distributed data system, you probably usually use horizontal scaling. You add more nodes to it. Right? Dimensional modeling is how you would structure your, for example, this is usually used in warehouses, but this is something that I don't use a lot. I have used it I think like early this year, there's a little bit of use case, but haven't released a lot. So this is how you design. Ito yung mga star schema, snowflake schema, that kind of thing. So how do you design your tables and connect them with each other, right? But if you have already existing tables, it's difficult to pull off. So in my particular case, there was a table that has to be created, and it would be a sort of dimension to a fact table, right? Anyway, relational databases. Let's move on. MySQL, this is just the normal ones, right? We have MySQL, Postgres, MariaDB. This one's cloud. There are many like alternatives to this. Depends on the cloud. This is just one example. So MariaDB is just a fork of MySQL. Postgres is a powerful na relational database with a lot of features. For example, like nesting ng mga objects, and also like full text search. Anyway, I'll go for it if you want to check it out. So one note here: understand the difference between document, wide column graph, and key value NoSQL databases. Let's just make it super quick here. If we can try it. These are really huge topics on their own, so we can just try and break this down super quick. So document is parang nag-stick ka ng JSON inside inside your tables. Essentially parang siya ganun. So if you a document is essentially parang a JSON document. So you can think of it like that, right? Meron kang may document ka with a couple of fields, right? So but it doesn't have to be strict with regards to, for example, with comparison to relational database na may tables ka, kailangan ito yung schema. Kay document, walang flexible yung schema niya, schemaless. So wala akong pina-follow na schema. Okay, pag mag-query ka tapos wala yung column na yun, hindi null siya. Ayun. So ganyan sa sa document based. So MongoDB, may documents ka rin, Elasticsearch same, tapos indices, right? Yeah, you use indices there. And I have never really used CouchDB. Pero Cosmos DB yung pinag-usama ko kanina is essentially what I was talking about dun sa CAP, right? So this is also big because this is also cheating kay Cosmos DB, because Cosmos DB can be document, wide column, graph, and key value. So Cosmos DB actually falls onto this whole category. Every single one of those, Cosmos DB can be document, wide column, graph, and key value. So anyway, let's talk about for a bit. So document kasi sa Cosmos DB meron siyang Mongo API. So you can use it as if you're using MongoDB. Okay. So wide column naman is essentially, di ba, kay relational databases meron tayong mga columns, right? May tables tayo, may columns sila. Ito yung particular schema natin. Kaya column, we can have columns that have columns essentially, right? So wala tayong limit ng columns natin doon sa parang parent columns natin, pero may limit yung natin, may specific schema yung bigger columns natin, pero inside those no, you don't have really limit. So it's just, that's why it's wide column, kasi it's can be a really wide, your rows can have multiple columns, like super raming columns, and you don't have a limit. Hindi siya well, may technical limit obviously, pero theoretically there's no limit to it. So then graph is essentially you have data nodes that connect each other. It's just basically explains itself. So essentially parang, for example, we have a Facebook and you have a friend and you want to figure out who are your friends' friends, right? Who are all the friends of your friends, right? So we can do that in in a graph database more efficiently than a normal database, right? Something like that. Yun. So key value is just like parang if you're getting a value from a JSON file, right? So you send it a key, you get a value. That's essentially it. That's what makes these really quick. That's why ginagamit sila sometimes as cache. Kasi you just give it a value and you get the value immediately, right? So give it a key and you get the value. So it's super quick. Ayun. So again, si Cosmos DB can be any of these. So si Cosmos DB merong Cassandra API. Si Cosmos DB meron siyang graph na API, then I forgot what it's called. And meron din siyang parang key value na API. So this is actually like a lie. This Cosmos DB actually falls into all of these. So yun. And also it can be a sort of relational din. May SQL API din siya. So you know, one size fits all. So data warehouses, we'll talk about these more, pero ito yung mga popular ones. Wondering wala dito yung Databricks, which is a lake house. So maybe technically wala siya dito kasi di siya warehouse, lake house siya, pero lake house is like both a data lake and a data warehouse. So I don't know, man. Pero ayun, so here are the examples. Yeah, I guess. Yeah, personal favorite ko dito is actually ClickHouse. Let me see. Azure signups here is, as far as I know, ito yung pinaka-comprehensive out of these ones. It essentially allows you it allows you to not just store data as a data warehouse. It also allows you to spin up like Spark instances as well within signups itself para makapag-process ka that immediately there. Okay, pero as purely data warehouse, my favorite would probably be ClickHouse, right? Super quick, right? Ayun. So may mga slight differences din to, obviously. Ayun. Moving on. So cluster computing fundamentals on the left. Apache Hadoop, hindi nawawala to. So I actually try to veer off like Apache Hadoop like based ecosystems right now. So it's not really a fun experience. Pero like if you're in the big data space, so hindi mo talaga, sorry. Wait. Come on, there we go. So si Hadoop hindi mo talaga matatakasan pag nasa big data space ka. Okay. So pero I try to avoid it. May mga places talaga na may modern data stacks, so I try to look into those instead. Currently in next paper I'm working at, we don't use Hadoop. Use something else, right? So it is still something that will handle ano ba to? So it is still something that will handle huge data, pero not Hadoop. That's actually we're using essentially yung Databricks, right? So HDFS is the Hadoop Distributed File System. Essentially, this is the file system that's being used by Hadoop. This has the ability to like make processing faster because of how it stores files essentially. So MapReduce is a way of processing. Essentially, you break down your files into multiple pieces or whatever, break down your data multiple pieces, and then you process them. That's the map part. You process them simultaneously. So parallel processing, and then after that you reduce it into a single thing, and then you return it to the user. That's essentially MapReduce. Okay, so if you've used like map and reduce or in JavaScript, it's essentially that but big data. Okay, so but this is just the process. That's just the same thing as well. Lambda Kappa architectures are essentially how you design your data flow essentially. So you can have like hot and cold paths, and you have so essentially that's what Lambda Kappa architectures are. You can have your cold paths wherein you store data, and you have your hot paths wherein you reference your the data you've stored as well. So yun, depende sa kailangan mo. You can use Lambda or Kappa architectures. May small silang difference, right? So managed Hadoop, Well, ito yun, yung mga to. Essentially, I think this has changed na. So, Managed Hadoop is essentially you don't have to deal with Hadoop when you spin it up. It's automatically a Hadoop cluster. Um, I don't know. Data Lake kasi right now in Azure, it's ADLS na. It's just you click a button. It's not really Hadoop, pero the sort of the API of connecting to it, if you're using a Hadoop cluster and you point it to an ADLS one or ABFSS, was that? If you point it to it and you use the same commands as you do with Hadoop, it would still work, right? So, but yeah, I don't really feel like using these anymore if I can help it. Right now, like I'm fine with S3 or with ADLS, which is essentially Azure Blob Storage, and just you click a button to become, and it becomes a data lake, right? We'll talk about what data lakes are in a later video, right? You'll be surprised at how simple it is. Right, so batch processing, right? We have a couple of things in here. We have batch, hybrid, and streaming. So you can see here that so batch is you deal with data by batch, and streaming is you deal with data as it comes in, right? Now, there's also the hybrid one that can deal with both batch and streaming. Okay, so that's why they're hybrid. So Apache Pig essentially write commands to like move your data, right, to process your data. And Arrow is essentially in memory din na batch processing, right? And data build tool DBT is a fun tool which like essentially like does a lot of things. Then like modeling your data, it's part of it as well. Or yeah, data build tool is not just like a batch data processing thing. It's a bigger, especially right now, it's a bigger thing than that. So maybe we'll look at this then as well someday. So yan, hybrid, we have Apache Spark, Beam, Flink, NiFi. So I'll just pick your poison, but the most popular one here is Spark, right? NiFi is one that has UI, but I don't really feel like it's good with, for example, with scaling, right? Honestly, so you're better off with Spark, honestly. Just use something on top of Spark, right? Something like Databricks or something else, right? There are a lot of them. So I would, my personal, his recommendation here, or their team's recommendation here is actually for batch it's DBT, and for hybrid it's Beam. For me, I'd also, in this particular list, I would also say like DBT is pretty good in this list, but DBT is not essentially just batch, right? For hybrid, Spark, and also there are times that you can actually use Arrowflight with Spark, but it's something that I don't really use. It's especially useful if you're converting between like data frames to data frames of pandas, for example. So it depends, right? In my particular case, I'm not really using that. And then streaming, I would also say that Kafka is pretty good, right? No, Kafka is pretty good. Standards, right? So messaging, actually a lot of other options for these, right? So AWS we have SNS and SQS, we have PubSub, Google, and for Azure there's actually a lot, not just Service Bus. There's also like event streams and event hubs. It depends, right? But yeah, for messaging, that Service Bus is correct. But for streaming, we have like Azure event streams and event hubs. There's a difference as well. I just forgot what it is. Just keep forgetting things. So for workflow scheduling, they prefer here Airflow. I prefer none of these. Essentially, scheduling, what happens here is you can schedule particular jobs, right? So that's what the name entails. But essentially, you can have a flow. For example, you can have a dependency graph. For example, if one task runs, yung susunod is mag-run lang pag matapos yung una, right? And same, you can have multiple tasks na mag-run after ng isang task na, for example, right? So for example, may task ka na mag-run for processing one table, and maraming tables pala na nakadepend sa particular table na to, mag-run lang yung mga processes na yun that rely on this, that creates multiple tables that depend on this one table after matapos yung processing for this one table, right? So this is just essentially a graph, right? So in this case, this mga suggestions na to, I prefer none of these. I probably like Google Composer would be the best of all of these. Pero I actually prefer something else. Like for example, well, in Databricks, which is what we're using, essentially, it's built in, so you don't have to worry about that. But before I actually used yung built-in, I was looking at Prefect din, which is not in this list, which is also nice. And marami din iba actually, like Orchest. Although Orchest is not for not for distributed ones. I have not actually tried using it for or testing it out for like multiple nodes. I have not tried. Pero it's an easy way to orchestrate, especially if may mga standalone ka, especially for machine learning. Like Orchest is pretty nice. Pero for big data na workflow scheduling, I don't like using these honestly. Anyway, so and then but yeah, workflow scheduling, it's like a graph, pero the thing is, one thing that you should note is that data does not flow through that graph. Okay, so it's just parang separate tasks. After this runs, mag-run yung next, so dependency lang, pero the data does not actually flow. Yun. So monitoring data pipelines, you use anything really, like these guys, Prometheus, Datadog Sentry, could also use like the Elk stack, which is napag-usapan na natin yung yung Elasticsearch. It depends, right? Pero sometimes it is already built in din, right? And there's also, for example, if machine learning focused ka, there's also YLogs, which is not here. And that's fine. There's also networking. Obviously, to some extent, you need to learn. For example, kasi nagkaroon din kami ng issue before kasi we try to make here at NextPay, we try to make our not just our application secure, pero yung data pipelines namin secure to some extent. Right. So, separate talaga yung environments namin. So, there's sometimes then that there's a thing then that happens na kailangan mo mag-connect talaga sa isang data source and you don't have access to it. So you need to know like nasa ang network ka para like you can do something like VPN peering or actually give you particular access lang talaga given a role, right? So that's something that you need to know. Then how to secure your assets. That's why you need these. All these. So I'm not gonna talk about them obviously. So ayun. AYAC, infrastructure as code. Well, you need to use these. Then depende. So in our particular project, for example, we use Docker a lot. We use Docker a lot. Marami kami pinagagamitan ng Docker. Okay, it's not just like creating a local setup, for example, or even just a lot of things, right? So Kubernetes might help then, right? There's also some people that actually like do distributed data work on Kubernetes, pero like, your call. It's not something that I do, pero it happens. And also infrastructure provisioning, right? This is also something that you can do. We prefer making our everything declarative, right? Like the Terraform, Pulumi, well, actually like Pulumi is like parang programmatic based din, which is pretty nice din. Which is something that I don't know if parang din to some extent yung bicep, which is something that we use in Azure din. But yeah, the most popular one here is I guess Terraform, right? But I've seen a lot of people have success with Pulumi din. Pero yeah, essentially it allows you to define your infrastructure as code. So you have some sort of configuration, and then you can apply or deploy it, and then it will be done. It will be created, right? So we like to do that, right? Marami din kaming bagay na there are a lot of things here na pinag-usapan natin na we also build declaratively. So for example, creating clusters and creating pipelines, we do it declaratively then. Even though we can do it with UI via like whatever platform you're using. So in our case, Databricks, we can do it via UI, everything via UI. Pero just prefer to have some level of correctness, right? So nobody can screw anything up by accident. Okay, especially in production, right? So we need to make sure that everything is correct. So we use some sort of tawag dito, declarative way of provisioning our assets, not just our virtual machines, pero like all of our other assets. Obviously, you need to know CICD din. This is very helpful. For example, how do you apply the changes that you made in your declarative sa mga ayak nyo, for example? How do you apply those changes once you push? But you can just mano-mano it, right? Pero hindi siya very fun, secure, right? Because you have your credentials nasa local nyo. So, ideally, credentials nyo nasa kay CICD, and then when it runs, ma-update yung data platform mo. Yun. So, IAM, Identity and Access Management, here, AD. Ba't walang iba? Ba't walang ibang IAM? Pero like, Azure Active Directory is yung pinaka-robust that I've seen anyway. So, it's also like Kerberos. Like, let's not talk about that. It's not fun. And there's also a couple of concepts here. This is something that I appreciate, right? Kasi yung marami tayong mga nakikita dito na puro tools lang, right? Except these, right? So puro tools sila, so you don't actually know what to know from these particular tools, right? You should be able to know particular concepts here, pero still, right? Not all tools. Ideally, may tool ka that does a good job of teaching you how to use it, pero sometimes hindi ganun. So, ayun. So, these are pretty nice things. Then, legal compliance, encryption, like different levels of encryption, and all in encryption in different pa rin, so like encryption at rest, encryption in transit, also encryption while in operation, yung mga homomorphic na encryption, whatever. And then key management, obviously, where do you store your secrets, right? So ideally you store it somewhere. You don't store it in plain text, especially sa mga like big data systems. Like a lot of people like don't know how to like store secrets there. You just put in as so like nobody's gonna see it naman in the application, so you just put it in plain text. No, let's not do that. And then data governance integrity, like how are you like policies, and then make sure that the data is correct, and making sure that you know who's accessing your data, right? Essentially data governance. So there are a lot of tools around these things as well. Legal compliance, I'm not sure what you would use for that. Encryption, depende din. Key management, depends kung nasan ka. Kay Databricks may built-in na secret, pero what we do is just get it pa rin din from a more secure place, like a key vault in whatever cloud you're using, right? Data governance, depende din. There are many tools that you can use for this. Usually may bayad. In Databricks, may Unity catalog, pero may mga other stuff din like Alteryx. Yun. Other stuff here, may mga nice to have na sila, is data visualization, although I don't think really it's a nice to have. It's something that you need to have, right? So in here, I would actually, from this list, I would actually use Power BI, honestly, like not just because I'm biased to like Microsoft. Have you seen the also because it's free on Windows, right? Tableau's like expensive as heck, pero like Power BI, you can just right click things and it will tell you things, right? This Power BI has AI built in with particular operations, like telling you what affected this particular data point. Why did it go down? Why did it go up? You can do that in a few clicks, right? It's so easy. It's so powerful. I just uses your laptop, right? Your Windows laptop though. So if you have a Mac, that's a problem. Pero if you have a Windows, nice. I think else here, there are a bunch of other like open source then. Well, Jupyter Notebook is like open source to some extent. Tapos meron din tayong, for example, Superset, and then Metabase. Metabase is pretty good if you don't code. It's pretty good. There's also Zeppelin, which is the closest to Databricks notebooks, right? So it can allow you to write in multiple languages, which is I do sometimes. So like, for example, I would SQL, tapos then after that, kailangan ko maggawa ng complex processing, so I do it in Scala or Python, and then after that, pag-SQL na naman ako. Right, so I do that. So in Zeppelin type notebooks, that's very helpful. In Jupyter Notebook, notebooks, I've never really seen anyone do that. But there should be plugins to write multiple languages in a single notebook. So I don't know. So machine learning fundamentals, if it's something that you really want to do, if you want to do machine learning engineering, so something you need to learn. These then I won't expand on these because this is not really like data engineering. Pero here then MLOps, there are a lot of they just talk about tools here, pero also you can also actually learn a lot of like concepts from these particular tools. Here they prefer Kubeflow, essentially. Like I assume they're using like Kubernetes. That's why you're using this. So TFX is a general recommendation. I would recommend MLflow actually in Databricks, right? Why? Because it also has like a bunch of other things na wala kay normal na MLflow and kay normal na TFX, for example, like feature engineering, right? And those not feature engineering, right? Feature stores, right? that kind of thing. Pero may mga one thing that is missing here din, actually maraming missing dito. For example, we have feature stores. So an example with that would be Feast and oh god, I forgot the other one. Feature flow ba yun? Feature something, right? Feature and there's also the concept of metric stores, wherein you it's a place where you put your metrics so they're easy to pull out. So the idea there is everybody needs to have one standard definition for a particular metric. So nobody so may gagawa ng visualization, mali pala yung pag-compute niya, may gagawa ng notebook, mali pala yung pag-compute niya. Ideally nasa lahat ng metrics nasa isang place lang, which is easy to access. Okay? So that's what metric stores are for. Yeah, so there are many na mga concepts pa and tools na wala dito, pero this is a good start. Right? So learning these will get you started, right? So yun. And ayun na nga, napag-usapan natin yung whole data engineering roadmap ng dito sa TV. At I hope na marami kayong natutunan dito. And then, if may mga tanong kayo, again, just comment sa video na to. And also, please don't forget to like and subscribe dito sa channel na to. And with that, I will see you all next time. Peace.